Hello everybody. So a lot of people have been talking about Chat GPT this week. I will be no different. We are going to be putting Chat GPT 4, the latest iteration, just in text version. We're going to be putting it through its paces with some mathematical questions. So of course computers are very, very good at raw computation. They've been very good at that for a while. That's not what we're going to be testing today, although I do just want to demonstrate that ChatGPT is very, very good at arithmetic in natural language. So if I ask it to do something like this, what is the sum of the first, let's say 30 odd numbers? First 3 odd numbers. Let's see if it understands what I mean. Find the sum of the first 30 odd numbers. We can use a formula for the sum of an arithmetic series. The sum of an arithmetic series can be calculated using the formula blah, 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 blah. For odd numbers, the first number is 1. That's good. The last number is the 30th odd number. There we go. The sum of the first 30 odd numbers is 900. So it's very, very good at doing things like that. What I'm going to be doing today, though, is be putting GPT-4 through its paces with some slightly harder reasoning problems. And these are ones where I've basically been trying to catch GPT out. And let's see if a few days later, if we can still catch it out. So the first one we're going to look at is testing whether some numbers are prime. Yeah, so let me give it this one. Is the sum of 2 prime numbers ever prime? Yeah, so it's still giving the wrong response. So last time, actually, no, it's still, last time I did this, it did actually say no, there are no exceptions. It seems to have improved itself. So yeah, it's caught the example where 2 plus something else can also be a prime with twin primes. So this is an improvement, actually. When I tried this last week, it gave me a different answer. Exactly why it's giving me a different answer now, I'm not sure. I'm not sure exactly how this thing is learning, but it is. That's pretty good. All right, let's see if some of the other tests. So this is another good example. So I give ChatGPT a really big odd number to the power of another really big odd number. Okay. And maybe just to make it even more extreme, I'll do that to the power of a really big odd number. Okay, actually it doesn't even need to be odd, does it? Sorry, that should be odd. There we go. So I take an odd number to a massive power, and then, which is itself to a massive power, and then I'm going to add 17 to it. And I'm going to ask, is this number prime? Well, a human would look at this and think, okay, I'll never be able to compute this. This number is just incredibly big. However, what can I know about this number? Well, it is an integer to the power of other integers, so it must be an integer. And it is an odd number to the power of an integer, therefore it must be odd. Now, if you add 17 to this, it will be an odd number plus an odd number, which is an even number. Therefore, it can't possibly be prime. Let's have a look if it can work this out. So to determine if the given number is prime, we need to check it has any divisors other than 1 itself. However, the given number is extremely large. Okay. Here we go. When an odd number is raised to any power, the result will be an odd number. If you add an odd number in this case to an even number, very interesting. So it almost got there, except it made this very, very small mistake here. When you add an odd number, in this case, the result of the exponentiation, to an even number, 17 is not an even number. However, it has got the correct result. There will be an even number. So this is a real improvement. Let's see if we can test it a little bit further, and we'll give it some odd number to the power of an odd number to the power of an odd number. So these numbers are just going to get really, really big. One, two, three, four, yeah. Plus. Now let's just try this again, but with 7. So let's see if it can extend the same reasoning, even when the numbers themselves probably become even bigger. Let's see if I can ask it, is it composite? Just analyzing the expression. Both the left and right parts of the expression are odd numbers raised to odd powers. Very good. As a rule, when you add two odd numbers, the result is always an even number, since all even numbers except very good. Okay, so this is better than it was the other day. The other day it completely failed. Okay, so far it's doing really quite well, and doing better than it was the other day. Let's look at something to do with that's not to do with prime numbers. So we're going to talk about something called Friedman numbers. Friedman numbers are a type of number where you can reconstruct the number from its own digits. So for example, let me just type this: 126 equals it equals 6 times 21. So using the 1, the 2, and the 6, you can create a mathematical expression that gets you back to the original number. So that's a Friedman number. Let's see. Okay, let me take a number that I know is quite large. So let's take 5 to the power of 15. Okay, let's take this number. I know this is a Friedman number, by the way. I'm not going to explain why, but I know it is. Is this a Friedman number? So it knows what a Friedman number is. That's no surprise. It's searched the internet. Yeah, this is very interesting. After analysing the given number, it becomes clear that it's not a Friedman number. So it's a very human way of putting it. It shouldn't be clear that it's not a Friedman number. The reasoning here is not correct. It says there's no obvious way to create an expression using the digits of the numerator that would be this. Okay, let's try something else now. Let's try 6 to the power of 16. What's that number? Okay, that's a little bit too big. Let's try 6. Right, this number also should be clearly a Friedman number. I won't go into detail why. Is this a Friedman number? Same kind of reasoning. Yep, it really doesn't know how to approach this problem at all. If you do a prime factorization of this, you'll find that it's actually just 6 to the power of 15, and then you can use the digit 6. So it has come up with something, but I don't think that's quite right. Sorry, where was I? Yep, so this one thinks it's got an expression, but actually it hasn't used all of the digits, but it's under the impression that it has. So it's worked out it's a Friedman number, but not for the right reasons. And also, I think if you were to check this expression here, you would find that it's not anywhere close. Not anywhere close what it says it is. So it can't even do basic maths in this case. So it's created this very confident answer. There's a total failure. Now there's another challenge like this, which is called the 4 fours challenge. Yeah? So let's see if it knows the 4 fours challenge. Do you know the 4 fours challenge? Yes, the 4 fours challenge is a classic mathematical puzzle that involves using exactly 4 fours and a set of basic arithmetic operations, addition, subtraction, multiplication, division, exponentiation, roots, and factorials, along with parentheses, sometimes square decimal points, by the way, to represent different numbers, usually integers. The goal is to create expressions for as many consecutive integers as possible. And now give some examples. Good, so it's given a pretty good summary of this. It's given it a little bit too confidently in the sense that sometimes people allow you to use the recurring sign, sometimes people say you should use a decimal point. There's no 1 4 fours challenge, but it seems to get the basic idea. Okay, so let's try the same idea, but with 6 sixes. Create a list of the first 50 positive integers using only 6 sixes. And here it seems to fail tremendously every time I've tried it. I don't know why it's just hung up. No. I don't think I used all my... No. Let's just give it a moment. Here we go. Right, let's try and regenerate the response. Here we go. The 6-6 challenges use exactly 6-6 in a set basic arithmetic. Right. As you can see, it's really starting to go quite wrong here. It's already introduced a 5 here. Hasn't quite got the idea. Let's just try and check the arithmetic. It says 1 times... yeah, the arithmetic on this doesn't even check out. In fact, maybe none of these check out. This is a really interesting example. It seems to be trying to copy some sort of pattern that it's seen before, maybe in the 4 fours challenge, but it's completely failed. Completely failed to get the gist of it, and now it's giving me a load of random stuff. Yeah, none of these even make sense. I don't know. I can't bother to check them all, but I think we can probably say that it can't get these 6 sixes. This is quite interesting. This is something that human beings, I think, are still far superior at, is playing with numbers, being creative with numbers. Raw computation, it's got us. But yeah, these playing around numbers, Chat GPT can't do. Yeah. This is just embarrassing now. I want to stop generating. Now, I want to give it another problem, and this will be the last problem I give it today. And this is an interesting problem in the sense that it's a bit like an Olympiad problem. I think I got this one off Twitter. Let's give it here. So it's going to be 9m plus 16 equals A, and 16m plus 9 equals B. And I'm going to tell it that A and B are both perfect squares. And so what are the possible values of m, possible positive integer values of m? Now, I suggest if you're mathematically inclined that you stop and the video here and you try to find out some of the solutions. The interesting thing is that there's two quite obvious solutions. The hint there is to use a Pythagorean triple. Let's just go for integer values, actually. But then there's a third, much higher number, which you can't really arrive at via inspection. So I wonder if Chat GPT will be able to use both types of reasoning. Let's have a look. Yeah. So it's understood it's got a system of equations. It rearranges them. Okay. So it's just doing some algebraic rearrangement here, which is fine. Nice. Good. This is reasoning quite well. So it's found 3 lots. That's really good. Okay, this is really impressive because the other day I gave it a similar problem and it couldn't do that. By the way, for some reason it stopped. I think because I just reached the character limit, but this is on track to solve it. If you do 4 squared minus 16, you get 0. So it's found all of them. The interesting thing is that there are 2 solutions which you can find by inspection, which is just m equals 1, and the last one, which hasn't been generated, m equals 0. But then you have this third one, m equals 52, which can't really be reached just by inspection. That makes you wonder if 0 and 1 are the only 2 solutions. Last time I tried a problem like this, it failed. This time it really seems to have got onto the right track straight away, and that has beautifully worked out. Now let's try and give it just something really quite abstract, like even a problem that I don't know, and we'll leave it at that. So what is the biggest number that can't be written as, let's say, the sum of the cube square, the sum of an integer, its square, and its cube, sum or differences. Let's see if it can solve this one. Yeah, so it seems to have laid out a mathematical research program. It's testing these. Right, and there you go. So it's laid out a mathematical research program. It's begun it. It found one number that couldn't be written for in a particular way using a particular sum or difference of an integer, a square, and a cube. It hasn't quite got that right, and then it's just decided that must be the largest number. So it's mistaken the idea of the largest number it has found with the largest number that it exists. So I think that's probably a good place to stop today. That's just a good example of putting Chat GPT through its paces. I think it's done pretty well. I think this is impressive stuff. The main thing that concerns me is when it fails, it seems to do so completely unaware that it's failed, and it fails in ways that are very, very hard to predict. It's very hard to know when it's going to get something and when it's going to have difficulty with it. And having a look at all this algebra stuff, it makes it seem like it has an exceptionally good grasp of arithmetic, and yet in this one, for some reason, it thinks 1 times 6 minus 1 minus 1. It thinks that 1 times 4 is 1. It's just stupid. Anyway, I hope you've enjoyed me putting Chat GPT through its paces. I think I'm going to do more and more of these. I'm going to go and explain some of the solutions myself sometimes, and then I'm going to see if Chat GPT solves it the same way. Bye-bye for now.